Hi everyone. In our last video, we studied about an introduction to the study of nucleus, like how small is the nucleus and the nucleides and their representations. Then we studied about isotopes, isobars, and isotones with examples. So in this video, we are going to study about radioactivity. So radioactivity or the studies related to it or its initial, like how humans started to learn about natural radioactivity. It's through a serendipity, or we can say that was an accidental discovery. So serendipity means accidental discovery, like it was a eureka moment, something like that. So uh, in 1896, Henry Becquerel was a scientist who noted this kind of radiations or something for the first time. So what he was doing is he was having potassium uryl sulfate, which was covered in a black thick paper, and the same drawer he was keeping that potassium uryl sulfide in a covered with a which is having a cover in a drawer, and the same drawer he was having a photographic plate was there. So his observation was that photographic plate, it was having some what to say, it has already started to degrade or something. So what his observation was, some radiations could penetrate through the wrapping of the potassium uryl sulfate, and it could affect the photographic plate, which was also wrapped in a black paper. So at that time nobody knows what was the cause behind the degradation of this photographic plate. So at that time there comes a famous scientist, the couple scientist, we can say, Marie Curie and Pierre Curie. They realized from their studies that there is an emission of some radiations from the uranium salt, like the potassium uryl sulfite was the salt. Potassium uranyl sulfate was the substance they were studying. So there was some emission of radiation from this uranium salt as a consequence of the nuclear process, which will be containing. So that certain other elements also will be there, like thorium, were also associated with such properties. Later only they came to know, there are many other elements which shows the same radioactivity. So their studies in fact led to the discovery of this radioactive elements, like polonium and radium, so which is having the same kind of properties. So they are the people who coined the name radioactivity to describe this phenomena. So radioactivity is a phenomenon of spontaneous emission. So there is no driving force. So it will be emitting the radiation by itself. It's a spontaneous emission of certain radioactive rays by the nuclide. So that is radioactivity. Radioactivity is basically, it's a spontaneous emission. You have to note the term spontaneous emission. Nobody is forcing them to do, or nobody is forcing them to emit radiation. It's a spontaneous emission of certain active rays by the nucleides means what are the constituent present inside the nucleus. So, and it's a nuclear property which will be which will be involving the spontaneous decay of an unstable nuclei. So we can say it's a property of an unstable nuclei. So basically we can say an unstable nuclei will be emitting some radiations or some kind of rays for making the unstable nuclei a stable nuclei. So this is a property of an unstable nuclei. the phenomenon is completely independent of the chemical state of the element, as well as there will be, of course, if an element has to emit some radiation, it is their chemical property, it's their chemical property, purely chemical property, but there will be some physical conditions which will be which will be ruling these kind of these kind of chemical properties. Like if it's understood, like if something has to emit a radiation, it is their chemical property, it is purely the reactions going inside the nucleus, that is the nucleides. So there are some physical conditions which will be ruling these chemical properties, like temperature, then pressure, etc. So radioactivity associated with a naturally occurring substance, like some substance by birth, or the natural substances have the tendency to emit these kind of radiation, like uranium, then thorium, then polonium, radium. These all are examples of some naturally occurring substances which have the tendency to emit these kind of radiation. So that is known as our natural radioactivity. So these are some substances which naturally have a tendency to emit these kind of radiations. So this is all about our natural radioactivity. Now we are going to study about the types of radioactive rays. So behavior of the radioactive rays in electric field and magnetic field reveal that there are having three kinds of different radiations. So basically, firstly, when Marie Curie and Pierre Curie were studying about the radiations, they found many observations, and to know more about the characteristics or the properties of these kind of radiation. So these kind of radiations were mainly they've studied more in the field, or with the help of electric and magnetic fields, so we could understand more about these kind of radiations. So we could find there are three types of radioactive rays, and they are our alpha rays, beta rays, and gamma rays. So we'll see how they studied, like how they discovered that three different kinds of rays are there by using this electric and magnetic fields. So the method of separation of these three rays by the action of electric field and magnetic field, I'll draw here how they discovered it. So in here we are going to study about types of radioactive rays. So we know there are alpha, beta, and gamma rays. These are the three rays. So for that, here I am drawing what is the experimental setup they have used to separate these kind of rays. So here is the experimental setup, or the method of separation of our radioactive decay with the help of electric field and magnetic field is represented in this diagram. A little of the strong, or the most dangerous, we can say, radioactive material we are keeping inside a small depression or on a small hole which is made in the lead block. So lead is having, why we are choosing lead is because lead basically has a capacity to stop the propagation of a radioactive radioactive radiation. So lead basically block the propagation of the radiation. So that's why we are taking a lead block which is having a depression or small hole in that. So radioactive these emissions will be going on this one direction. So nowhere by these place the radioactive emissions will be going. So we will be getting a fine narrow beam of that radioactive or we can say the radiation. So then what we are doing is these emitted radiations are subjected to the action of an electric field. So here when we are keeping a negative and a positive terminal, so these radiations will be going in a focused manner. So what is the science behind it is, we know positive charge will be attracted towards negative charge and negative charge will be attracted towards positive charge. I'll repeat once again because this is an important thing which you have to keep in mind to understand this one. We know that positive charge will be attracted towards negative charge and negative charge will be attracted towards positive charge. So we can say when I am applying this electric field, here you can here I am giving the negative potential and here I am giving the positive potential. So what happen is our radiation, if it is having a positive charge, it will be moving towards this negative terminal, and if my radiation is having some rays which have a negative charge, it will be moving towards this positive terminal. So what happened actually in the studies is one portion of the rays get deflected towards the negatively charged plate. So by that we can say our radiation is having some positive rays, and that is our alpha rays. And if my radiation is having some particles or some rays which are having negative charge, it will be moving towards the positive direction. So that was our second observation. A second portion of the rays from our radioactive material gets deflected towards our positive plate. Obviously we can say that, so our radioactive material is having some rays which have negatively charged particles. And we know if we are having some neutral things, a neutral thing which will not be affected by any charge. So that is our third observation which we got by the studying the radioactive rays in the electric field. That is the third portion, from this radioactive material we could say that there is a third portion of the rays which goes without any deflection. That means there is no change in its path, or it is not disturbed by either the negative terminal of the electric field or by the positive terminal of the electric field. So the third portion of the rays could go directly towards the photographic plate in a straight line. So that is, we can say if it is not having any deflection in its path, we can say it is neither affected by positive nor by the negative negative plate. So we can say we have an uncharged particle also, that is we are naming that as gamma rays. Gamma rays are basically neutral. So we could see these kind of rays by the impressions, or by the, if a positive ray is going towards this side, so here we will be getting some mark on this photographic plate, you will be getting a mark. So and because it is deflected towards the negative, we can say it is having a positive charge. So alpha rays are something which is having a positive charge and deflected by the negative terminal. Beta rays are something, or some rays which are having negative charge and deflected by positive terminal, and gamma rays are something which do not have any charge and it is not at all affected by the negative and positive terminal. So thus we could find there are three types of radioactive rays, alpha, beta and gamma, from this experiment. So now we know there are three types of rays. Now we are going to for a comparative study of the three rays, or the characteristics of three rays, alpha, beta and gamma rays. So here you can see a summary of different types of rays. I have written in a tabular form regarding the characteristics of each and every radioactive rays. So first, moving on to the alpha rays, here you can compare each and everything. Each points you can compare here. In that way I have written. So first we'll study about alpha rays. So alpha rays are deflected by the electric and magnetic field, and so we can say, and we have like the previous portion when we discussed about alpha rays, we could see alpha rays was deflected towards the negative terminal. So we can say they are having a positive charge. Then what is an alpha ray? Alpha ray consists of, they consist of 2 units of a positive charge, and we can say they are having an atomic mass unit of 4. So we can say they are equivalent to a helium nucleus, or an alpha particle we can compare it to helium nucleus. So that is all about the nature of an alpha ray. Then coming on to the velocity of alpha rays, they can travel almost equal to 1/10 the velocity of light. Then their penetration power of alpha rays are having the least penetration power. If I'm having a aluminum foil which is having almost 0.1 nanometer thickness, and if this is the aluminum foil of 0.1, okay, let's take this. If I'm having this is the aluminum foil which is having 0.1 nanometer thickness, and if an alpha ray is coming, so this alpha ray could be stopped by this small aluminum foil, or this aluminum foil which is having 0.1 nanometer thickness. So it cannot move by penetration. So these are having the least penetrating power, but because this alpha rays are having high momentum, these are having highest penetration power. So if somewhere alpha rays are passing, it could ionize the whole gas surrounding the region. So these are having the highest penetration power. Then we could see from the experiment, they could affect our photographic plate. So this is common with every rays. Alpha rays, beta rays and gamma rays could affect the photographic plate. Coming on to the beta rays, we know alpha rays are positive and beta rays are negative. Then beta rays can be compared with an electron. So alpha rays we could compare with helium. Here beta rays we could compare with an electron, and its mass is equal to electron, and it is having one negative charge. So it is beta particle are basically equivalent to electron. Then the velocity of an beta particle, it will be ranging from 33 to 99% the velocity of light, and it is having 100 times more penetrating power than our alpha particle. So basically beta rays are comparatively more stronger than beta rays. So we can say as a comparison, to compare our alpha rays and beta rays, we can say if I'm having aluminum sheet of 5 millimeter thickness, then only I can stop the beta ray. I'll repeat, if I'm having an aluminum sheet of 5 millimeter thickness, I can stop my beta ray, but alpha rays can be stopped by 0.1 millimeter thickness aluminum sheet. So we can say these are having 100 times more penetrating power, and these are having less penetrating less power of ionization, or it ionizes the gases little bit lower than our how the alpha rays are doing. Then it also affect the photographic plate. Then comparing, so when we are moving on to our gamma rays, we know gamma rays are neutral. They don't have any charge. From our experiment we studied that these were not at all deflected by positive or negative terminal, and they are having, or gamma rays consist of electromagnetic radiations which are having short wavelength. Then the velocity of gamma rays is equivalent to velocity of light. That means gamma rays will be traveling with the speed comparable or with the speed equivalent to the velocity of light. Then gamma rays are having the highest penetrating power compared to our alpha rays, beta rays and gamma rays. These are having the most penetrating power. And so we can compare, like we can say as a comparison, if I'm having an iron block of 25 centimeter thickness, then also with that kind of thick block also we cannot stop the propagation of gamma rays. It means it can easily pass through human beings. So that's why these are most dangerous. Gamma rays are considered to be most dangerous. It can cause mutations and all in the cells. So we'll be discussing about gamma rays in detail in upcoming videos. Then gamma rays are having the least ionizing power. It cannot among the all, when we are comparing alpha, beta and gamma rays, these are having the least ionizing power, and it also affect our photographic plate. So in the next video we'll be discussing about modes of radioactive disintegration, modes of radioactive decay or radioactive disintegration, and group displacement, low, etc. Thank you.